Here we go with Glencoe Algebra 2, Section 1-4, Solving Absolute Value Equations. So today we're going to talk about Section 1-4. We're going to build on what we did in Section 1-3. In fact, the rest of what we're going to do in Chapter 1 is take those skills that we learned in solving equations in Section 1-3 and apply them to equations with different kind of special parts and special properties to them. So we're going to use those same skills and find out all the little intricacies that come with things like absolute value equations. So first thing we're going to do is define absolute value. So what is an absolute value? What does it mean, absolute value? The book defines absolute value as the absolute value of a number is its distance from zero on a number line. So let's get that in here. Distance from zero on a number line. Okay, so what that essentially does is that says we're concerned only with the distance and not whether this thing is positive or negative. So in the example here, we see that we have the absolute value of -4. Okay, so the absolute value of -4 is 4 because the value -4 is 1, 2, 3, 4 units away from 0. The absolute value of 4, the absolute value of +4, is also 4 because it is 1, 2, 3, 4 units away from 0. So absolute value, what do you do? How do you use it? Essentially what you're doing when you're using an absolute value in an equation is you are finding out the positive value that tells you its distance, the distance of a number, from a specific spot. And that specific spot happens to be 0. Okay, so just a quick example of how you might use this. If you were to see something like the absolute value of -7, you would tell me that that should be equal to the value 7. And if that's in an equation, you would then use the number 7, +7, moving forward. If you were to see the absolute value of something like 11, then you would strictly be using 11. So the absolute value, once you, and I like to talk about it as using the absolute value, once you use the absolute value, you are changing the sign of a negative number to positive that's inside the absolute value bars. And if you are using the absolute value on something that's already positive, no change is happening. We just are sort of stating that we don't need to do anything, that the absolute value is equal to the number. And that makes sense because, again, the absolute value tells you the distance from 0 on a number line. The absolute value of 20 is 20. It's 20 units away from 0. The absolute value of -40 is 40. It's 40 units away from 0. It doesn't matter that it's to the positive side or to the negative side. We're strictly talking about how far away are you from 0. And what we're going to see is that we need to be able to evaluate, sort of to use, please excuse my dear Aunt Sally, and evaluate, plug in values and calculate numbers and do the math in the right order. And that's what example 1 is going to show us. And then later we're going to look at solving equations that have absolute value bars in them. Okay, so here in example 1 it says evaluate an expression with an absolute value. So it's asking us to evaluate, which means plug the number in, do the math, and find out what it's equal to. So I'm going to start out by rewriting the equation and plugging the value for n, -7.5, into the appropriate place in the equation. So 8.4 minus the absolute value of 2 times -7.5 plus 5, other absolute value bar, equals, and that's what we want to know, equals question mark. What is this? Now, these absolute value bars, one here and one here, say whatever we end up with, once we have a single value inside, in between them, we're going to then take its positive. If it happens to be a positive number, we'll just take the number. And if it happens to come out to be a negative value, then we're going to change that sign and make it positive. And that's the value that we'll use in evaluating the rest of the equation. So how do you treat absolute value bars? So we're going to use, please excuse my dear Aunt Sally, PEMDAS, to figure out how to do the math here, because that's essentially all we're doing. And what we're going to do is we're going to treat the absolute value bars as a set of parentheses that have a special function. So once we can get it down to a single value, a single number, possibly with a negative sign, inside that set of parentheses, then we're going to evaluate or use the absolute value. So we're going to start out by doing the math inside there. We're going to go in the parentheses, essentially. There are no exponents, so the next thing we're going to do is multiplication. 2 times negative 7.5 is the first thing we're going to do. So we're going to become 8.4 minus the absolute value of negative 15 plus 5, other absolute value bar. You might want to make these kind of big to make sure that you don't confuse them with the value of number 1. But you can see that, again, we're just doing parentheses. No more multiplication, so I don't see any division. We're going to move to the addition that's inside there. 8.4 minus the absolute value, negative 15 plus 5 is negative 10. Okay, so you can see that this is good. We have a negative value inside our absolute value. And that means that now we can use the absolute value to say, hey, I know that what I really want is this value's distance from 0 on a number line. So I'm going to take my negative 10, and I'm going to rewrite this as 8.4 minus, and this negative 10 is simply going to become a 10. Now notice, I did not include the absolute value bars again because I have used them. And their purpose was to take the negative 10 and tell me to use just the value 10 being this number's distance from 0. And now the last step, since there's no more parentheses left, I have evaluated them, is to subtract 8.4 minus 10, and I get a final value for this of 1.6. So I have evaluated this equation by plugging in negative 7.5 for n, and I came up with a value of 1.6. So again, what we did is we plugged in, we treated the absolute value bars as a set of parentheses that has a special function, and at the end, when we got down to the point where we had just a value, just a number inside, no math to do, just a number inside the absolute value bars, we used the absolute value bars to change a negative value to positive, or to just leave a positive value alone. And we ended up with 1.6. So on the next screen, we're going to try the guided practice. Now's a good time to pause, plug these values in, make sure you're following Please Excuse My Dear Aunt Sally, and use the absolute value bars appropriately. Answers to these will show up at the end of this video. Go ahead and pause the video now and give these a try. Okay, now that you've given those a try, we're going to move on to example 2, which is actually going to ask us to solve an absolute value equation. Now, in this section, they go right to the real-world example in solving an absolute value equation here, because in these kind of situations, it makes sense to have a context for what you're solving for. And it turns out that we can read this and we can probably pretty quickly come up with the correct answers. And this is going to be all about the process and giving us an idea how to move forward in solving these equations. So I want to talk a little bit about that. So the example here says a standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. Write and solve an absolute value equation. Determine the least and greatest possible sizes for the head of an adult tennis racket. Now, most of us can probably pretty quickly say, all right, well, 100 square inches plus or minus 100 square inches plus 20 square inches is going to mean we could probably get as big as 120 square inches, and 100 square inches minus 20 is going to give us a value of 80. So 80 is probably the minimum. But what you need to do here is we need to understand that we're trying to determine the greatest and least possible sizes. Greatest and least. Now, they gave us the middle size and they gave us the range. And that's what this understand section here in the center is about. Essentially, what we need to take from this is that there are two answers here. We're looking for two things. We're looking for the maximum and the minimum. And so what you're going to see down at the bottom here is that in case 1 and case 2, right down here, here's case 1 and here's case 2, we have to solve two different things. We have to solve two different equations. So we need to talk about how to set this up. And then we need to talk about, when solving, how to break this into actually two different equations to help us solve, one for the maximum and one for the minimum. So it says the plan: when writing an absolute value equation, the middle or central value is always placed inside the absolute value symbols. The range is always placed on the other side of the equality symbol. So you can see here, right in the center, the central value goes inside the absolute value bars, and the range goes on the outside. So essentially what we're going to do is we're going to look for something, and I kind of want to rewrite this and kind of explain. When we talk about the absolute value, we're talking about the absolute value of x. X being the variable, the thing we want to find, either the max or the min. So we're going to have x minus the central value, which in this case is going to be 100, but we'll just put c there for now, the central value. And when you take the difference of those, the absolute value needs to be r, the range. So if we already know the answer, then we essentially want to see something like 120 minus the central value of 100 is 20, and the absolute value of 20 is, hey, 20 was our range. It was plus or minus 20 square inches. So that works out correctly. Now, you're not always going to know that. You're not always going to be able to as easily just know what the answer is. And so again, this is all about the process. Like I said, that was very simple to do in our heads. We take the 100, we add and subtract 20 from it, and it gives us the max and the min. But we need to go through the process and learn how to do this. And so what we're going to do is we're going to set up the initial equation. So they do that right here. Here's the initial equation. The absolute value of x minus 100, which is essentially what we just talked about here, and it has to be equal to the range 20, that plus or minus value. Now, what you can see they do is, in case 1, they're going to do something called a equals b, and I'm going to refer to that later as one of our two cases, and a equals negative b as the other one. So that kind of makes sense, because absolute values can come from two different places. You can get a value for the absolute value of 4. Remember, from our initial definition, we had the absolute value of 4 equals 4, and the absolute value of negative 4 also equals 4. So this value 4 can be acquired two different ways. And that's just what's happening here. That's what we're doing. We're going to use that fact. We're going to exploit that fact to help us solve, one for the max value with a positive b, and one for a negative value with a negative b. And that b value being the range, being the right side of our equation, is essentially what it is. So you can see that what we do is, for case 1, we have taken away the absolute value bars. Notice down here in case 1, there are no absolute value bars. There are also no absolute value bars over here. So essentially, since in this equation the absolute value is by itself on one side of the equation, we're now ready to split this thing into case 1 and case 2. And soon we're going to talk about the steps that we use to do that. And the first step that we're going to talk about is isolating the absolute value. And that's what we have here. The absolute value of x minus 100 alone on one side of the equal sign means that it's isolated. And when that happens, what we can do is we can get rid of the absolute values, and we can set one equation equal to whatever the value is on the right-hand side, leave it alone, and then we can change the sign and do it again for case 2. So that's where the minus b comes in. The a part is supposed to represent what's inside the isolated absolute value. The b part is supposed to represent what's on the other side. Case 1, a equals b, is the case where you solve it and you leave b alone. Case 2, where it says a equals negative b, says solve it but change the sign of b. Okay, let's move over and actually solve this one and see how to finish this out. So here we have, I've rewritten case 1 as x minus 100 equals 20, and case 2 is x minus 100 equals negative 20. So again, they're both x minus 100 because that's what was isolated inside the absolute value on the left. The first case is just equal to 20 because that's the original value, leave it alone. And the case 2 has negative 20 on the right-hand side because we've taken that value and we've changed its sign. And that's pretty much all we need to do. Now, this is just like section 1-3, where we're going to use reverse PEMDAS or SADMAP to help us solve this. And so I see here that I have x minus 100. So in order to undo that minus 100, I'm going to add 100 on both sides. That means this will become 0, and I'll be left with x by itself. And I add 100 on this side, and I find out that x is equal to 120. Now that's 120 square inches. That was one of those original values that was stated at the beginning here as one of the possible answers. In fact, that's the maximum value. And if we solve case 2, we have x minus 100 again, and so we're going to solve that the same way by adding 100 on both sides. That becomes 0 and leaves x. Negative 120 plus 100, though, leaves me with a value of 80, and that gives me the minimum. Now, we know that these are the correct answers, but I'm going to stress right now, and I'm going to stress over and over and over again, that it is going to be very important to check the answers. Check the answers. Check the answers. You need to take your answers, you need to plug them back into the original equation, and you need to check to make sure that they work. And we're going to see why in a minute, but you have to do this last step. Okay? You'll see that there are 2 possible answers. We need to make sure that both of those answers are good answers. So we need to check both of them and plug them back into the original equation. Again, the original equation was the absolute value of x minus 100 equals 20. Absolute value, x minus 100 equals 20. So we need to plug both of these in. So I'm going to start by plugging in 120 here on the left side for case 1. The absolute value of 120 minus 100 equals 20. And right now what we're doing is we're questioning whether or not that's true. So that's kind of a question mark. We want to make sure that it's true. 120 minus 100, I'm going to treat those absolute value bars like parentheses. When I do that, I get a value of 20 inside my absolute value. And again, I'm questioning, is it equal to 20? And the absolute value of 20 is 20. And so I find out that 20 equals 20, and that means check, this solution works. It's a good solution to my equation. 120 is a good answer, and I can go ahead and pen that in because I've checked to make sure that it works. I'm going to do the same thing over here. I'm going to plug in 80 minus 100 equals 20. The 80 minus 100 is inside the absolute value there. The 80 minus 100, again, inside the parentheses. Absolute value bars are just parentheses. There's no other math other than this subtraction. I get absolute value of negative 20. Absolute value of negative 20. Is it equal to 20? I know that when I have a single value that's negative inside my absolute value bars, I need to change the sign. And I find out that 20 does in fact equal 20. And check again, x equals 80 is a good solution because when I plugged it back into the original equation, it worked. Okay, so let's kind of make a little prescription, a set of steps here. What should you do when you encounter an absolute value equation? I like to give you sets of steps to follow that will help you when solving most cases. There are always those kind of special cases that you need to look out for, but I do like to give you a set of steps. Step 1 here is going to be to isolate the absolute value. I'm going to isolate the absolute value. So you want to have something that has absolute value bars by itself on one side of the equal sign. There can be some math in here, x minus 10, whatever it happens to be. You want to get that by itself and have something on the other side that should look like a number. It should just be something like 27, whatever it happens to be. But you want to isolate the absolute value. You want to get it to look like this. And then once it looks like this, the second step is going to be to remember that there are two cases. Set up two cases. There's a case where what's inside the absolute value, the x minus 10 part, we're going to call that A, is just set equal to B. And so you would solve something like x minus 10 equals 27. That's an equal sign. And then the second case is the A equals negative B case, where you would then solve x minus 10 equals negative 27, where we would change the sign there. Sorry, I went off the end of the page. But we would solve the same equation, except we're going to change the sign of the right side. So we're going to set up both cases. And then step 3 says solve both cases. You need to solve both of them. Solve both cases. And then what you're going to do in step 4 is that check. Check your answers. Check your answers. Plug them back in. Check. Plug them into the original. It's very important that we use the original equation. You're not plugging them back into these equations here. You're not plugging them back into the two cases. When you plug them back in, the original equation means this equation up here. That's the original equation, the one that has the absolute value bars in it. So you need to go all the way back to that original equation, and you're going to plug your values in there. And if they work, then they're good solutions, and then you can move forward. Okay, so I want you to go ahead and try to employ these set of 4 steps as you try the guided practice for example 2. So you have 2 equations here. It turns out that they're already set up for you, that they are isolated. That's not always going to be the case, but you're going to go ahead and set up your 2 cases, solve, and check your answers. Pause the video now and give these a try. Alright, now that you've given those a try, hopefully you did get 2 correct answers for both of them. They do have 2 correct answers each. We're going to move on and start to talk about example 3. With example 3, I want to talk about why it's so important to check your answers. And the reason it's so important to check your answers is because sometimes the answers that you come up with may satisfy the individual case equation, like the A equals negative B equation, but it doesn't actually satisfy the original equation. And sometimes, as in the case we're going to see here in example 3, there are no values that will satisfy that original equation. And when that happens, you need to report that the answer is the empty set. And the symbol that we use for the empty set is this symbol right here. It's sort of a circle with a slash through it. You've seen that before, like do not enter and things like that, so that should be a familiar symbol, but it means the empty set. The set of answers is empty. There are none. And one of the ways that that's going to manifest is shown here in example 3. So in example 3, you can see it says no solution. How do we know that there's no solution? So let's follow our steps. Step 1 was to isolate. Okay, let's list that over here so we get more familiar. We're going to isolate the absolute value. So the absolute value part is the 3x minus 2 inside those bars. And so what I'm going to do is I'm going to, since I'm adding 8 to my absolute value, I'm going to subtract 8 on both sides. That's a minus 8. I'm subtracting 8 here, and I'm subtracting 8 over there. So I'm left with 3x minus 2 on the left-hand side. And that's going to be equal to 1 minus 8 is negative 7. Now here's where we start to see this idea that, hey, there are no solutions here. The absolute value of 3x minus 2 cannot be a negative number. The absolute value cannot be negative. Remember, the absolute value is always the positive distance away from 0. So at no point, even with a value like negative 7 inside my absolute value bars, remember that the absolute value of negative 7 is 7. There's no way we can use absolute value bars to come up with a negative value. So when you see a situation like this, you need to state that the answer is the empty set. There are no solutions. And that's because we have an absolute value right here set equal to a negative value right there. And when that happens, you're just going to simply report there are no solutions. And again, this is why we need to check our answers, because sometimes our answers that we come up with are not going to satisfy the equation. In this case, we didn't even have to come up with answers to realize that there's no solutions. It kind of jumped out during the course of solving and getting ready to solve the problem. There will be times where we're going to solve for some answers, and then when we check them, we're going to find out that they don't work. And that's why that fourth check step is so important, and I keep stressing that. Check, check, check. Let's move over. Here's the guided practice for these example 3. It should be obvious at this point, since it's the guided practice for example 3, no solution, that there is going to be no solution for each of these. What you need to do is you need to take the equation solving process as far as possible when you're doing these in order to show how you know that there's no solution. So what is it about these that gets you no solution? Pause the video, take those as far as you can, and we'll move on to example 4. And move on to example 4. Now, in example 4, you'll notice that example 4 is called one solution. And that's important because what's going to happen here is we're going to solve this equation. We're going to solve it and find that we think there's 2 solutions, and when we check one of them, we're going to find out that one of the 2 solutions is no good. It doesn't satisfy the equation. So let's go through and use our steps. Okay, so step 1 was isolate. So it turns out that it's already isolated. X plus 10 is inside the absolute value. It's the only thing on the left side of the equation. And 4x minus 8 is on the right-hand side. Don't be concerned that there's a variable on the right-hand side. It doesn't matter. We're going to solve it the same way that we would a regular equation. It's not a big deal. Okay, so we're going to be able to jump right to our 2 cases. That's step 2. Set up your 2 cases. So I like to write this as the case A equals B, and over here I like to write out the case A equals negative B. I'm going to solve A equals B, then I'm going to solve A equals negative B, and then we'll go and we'll check both of the solutions. Okay, so A equals B is going to be set up as, all right, what's inside the absolute value? That's A. It goes on the left. X plus 10, okay, equal to B is the right side of the equation, and we leave it alone, 4x minus 8. We just copy it straight down. The other side, A equals negative B, A again stays the same exact thing, x plus 10 equals, now here we have to take the negative of the right side, or I guess I shouldn't say that, I guess I should say take the opposite. So I'm going to write this as the opposite of the whole side, 4x minus 8, like that. And so this side is going to be a little bit different because we're going to have to distribute that negative sign into the set of parentheses. So we'll do that. We'll solve that case in just a second. Let's work with case 1 here, A equals B. I think what we'd like to do is we'd like to get all of the x's on one side of the equation together and everything that doesn't have an x on the other side. So let's start by moving this positive x on the left over to the right-hand side where our 4x is. So we're going to start by subtracting x on this side. X minus x leaves none. Subtract x over here. This is going to leave me with 10 on the left-hand side. 4x minus x is equal to 3x minus 8. We're going to want to move that minus 8 over to the other side, and we're going to do that by adding 8 to both sides. Here we're subtracting 8. The opposite of that is adding. So negative 8 plus 8 becomes 0. We're going to add 8. 10 plus 8 is 18 equals 3x. We're multiplying x by 3. In order to get the x by itself, then we need to divide. So we're going to divide on both sides by 3. 18 divided by 3 is 6. 6 equals x. So we get first value, 6 equals x on case 1. And for case 2, we're going to have to go through and solve x plus 10 equals the opposite of 4x minus 8. So I'm going to rewrite this and distribute that negative sign in. X plus 10 equals, this was a positive 4x, and that's going to be a negative 4x. And we had minus 8, and minus times a negative is going to become plus 8. And you can see we have a different equation that we're solving here. And that means we're going to get a different answer. We should not get 6 again. Even though we kind of feel like we're starting with the same equation and, oh, we should just get the same answer. It's really not the case. We do get a different equation that we're solving for. We can solve this the same way, though. We can move the x over, so let's do that. Minus x, that goes away. We can subtract x. We're left with 10 here by itself. Negative 4x minus x is negative 5x plus 8. We're going to get rid of the plus 8 by subtracting 8 this time. So that's a different step because we had a different sign there. So plus 8 minus 8 becomes 0. 10 minus 8 is 2. And we get 2 equals negative 5x. And so we want to solve for x. And so what we're doing is we're multiplying x by negative 5 here. So I'm going to divide by negative 5. And when I cancel those out, I divide by negative 5 here, and I get negative 2/5 equals x. So I have my two answers. X equals 6 for one case, and x equals negative 2/5. I'm going to list those up here because I'm going to erase my work. X equals 6, and for this case we have x equals negative 2/5. I'm going to go ahead and erase the work that I have down here so that we can check. We're going to check our work now. That's the last step. The last step is to plug in to the original equation and see if our solutions work out. So, oops, some more erase here. There we go. Okay, so let's check x equals 6 first. So we're going to plug it back into the original equation. I'm going to write the original equation, and I'm going to plug the 6 in for x. So we get the absolute value of 6 plus 10, close my absolute values, equals 4 times 6 minus 8. And the question is, are these two sides equal to each other? I like to put the little question mark there above the equal sign so we remember what we're doing because it's all numbers. So we're going to evaluate the left side and use our absolute value bars, and we're going to evaluate the right side, and we're going to see if they turn out to be equal. So on the left, 6 plus 10 is 16. On the right-hand side, 4 times 6 is 24. 24 minus 8 is 16. Now, again, are these things equal? Is the absolute value of 16 16? Well, it turns out that it is. The absolute value of 16 is just a positive 16. We have used the absolute value bars. We get 16. 16 equals 16 is correct. X equals 6 is a good solution. We do need to check both of them, though. So now what I'm going to do is I'm going to plug in negative 2/5. Let's see. Negative 2/5 plus 10 equals, maybe, 4 times negative 2/5 minus 8. And we're going to go through and, again, do this math and see if this works out. Negative 2/5 plus 10 is 9 3/5. Is that equal to 4 times negative 2/5 is equal to negative 1 3/5 minus 8. When we do this math here, we see we can use the absolute value bars, and since this is a positive value right here, we don't make any changes. 3/5. Is it equal to negative 1 3/5 minus 8 gives us negative 9 3/5. Are these two things equal? They are not. We checked and we found out that x does not equal negative 2/5. So our one solution, as we noted up here as a title to example 4, is x equals 6. And this is a prime example of why you need to go ahead and check your answers. You need to check your solutions every single time. You need to check both of the possible solutions that you've come up with. Some of the equations are going to have 0 solutions. Some are going to have 1, and some are going to have 2. But you need to check your solutions. That fourth step, check your solution to make sure that the answer you're reporting is a good answer to the question. And remember, to do that, you're plugging the value that you get from your 2 cases into the original equation. Go ahead and solve guided practice 4A and 4B. These should have 1 solution each, so go ahead and check them out. Make sure you check both solutions. Pause the video now. Okay, these answers will be provided to you at the end so you can check your work. And what I like to do now is I like to just review a couple of important things, including the 4 steps that we use to do this. So even before that, the first thing I want to do is I want to remind you that the number of possible solutions for an absolute value equation varies. The number of possible solutions are 0, 1, or 2. It could have 0 answers, and in which case you would report the null set, it's 0 with the line through it. It could only have 1 solution, and that's a case where you would come up with 2 possible answers, and when you check them, you find that only one of them works in the original equation, and then the other possibility is that you come up with 2 answers, you check both answers, and it turns out that both answers satisfy the original equation correctly. So it's important to remember that there are multiple possible numbers of answers. And then the other thing I want to remind you about are those 4 steps. Step 1 was isolate the absolute value. Step 2 was to set up your 2 cases. And those cases again were A equal to B and A equal negative B. Step 3, solve both cases. And then step 4 is the all-important check your answer. Check your answer. Don't forget to check your answer. On the next screen, we're going to see the answers to the guided practice. Guided practice answers are provided here for you. Again, for 3A and 3B, we knew that there would be no solutions. And again, that's all about getting to the point where you are confident to say that there are no solutions and understanding that an absolute value cannot be set equal to something that's negative. 2A and 2B each had 2 answers, and 4A and 4B each had a single answer. So remember to check your solutions. Check. Remember that you can go to connected.mcgraw-hill.com for 24/7 book access. Today we looked at section 1-4 on pages 27 to 30, and your homework is located on the next screen. Please check your understanding 1 to 5, and then the odds from 7 to 13. Again, check your answers. Some of these things may only have 1 answer or possibly no answers. So the ones in example 1, up here at the top, 1 to 5, you are substituting in values and evaluating the expressions to come up with a value. And for examples 2 to 4, you're going to solve each equation and check your solutions. Remember that there could be 0, 1, or 2 solutions. Step 1 is to isolate the absolute value. Step 2 is your 2 cases, A equal B and A equal negative B. Step 3 is to solve, and step 4 is check your answers. I'll bring these completed to class, and we'll check your answers first thing. Thanks a lot.